This video discusses the minimum mirror height needed to see your full image as you look in a plane mirror. So this is our mirror right here, which is very large at the moment. And so the person wants to be able to look into the mirror and see from the top of their head to the bottom of their feet. So in order to do that, the person is going to have to be able to see light that comes from the top of the head or the hair, reflects off of the mirror and gets back into the eye. So in order to see the location of this reflection, we're going to draw a line that represents the location of the eyes relative to the mirror and the location of the top of the head relative to the mirror. So light would have to start off at the top of the head, strike the mirror and reach the eyes, and we know that according to the law of reflection that the angle of incidence has to equal the angle of reflection. So I'm going to put a line midway between the top of the head and the eyes, and then we can draw a ray of light that comes from the top of the head, strikes that midway point, and then comes back and reaches the eye. By picking the midway point, we know that we have the angle of incidence equal to the angle of reflection. And then we can do the same thing at the bottom half of the mirror from the eyes to the feet. If I pick a point midway between, light has to be able to come from the feet, hit the mirror, and then reach the eyes. And so as long as light can reach the eye according to the law of reflection, then the person will be able to see their feet in the mirror. So that means that I don't need this top half of the mirror, this top portion of the mirror from the midway point between the top of the head and the eyes, and I don't need the bottom part of the mirror from the midway point between the eyes and the feet. So I can take away that part of the mirror and I would still be able to see the full image. So the height of the mirror here must be exactly equal to 1/2 of the height of the person, because I took the midway point between the eyes and the head and the midway point between the body and the head, and so what's left is exactly half of the height of the person. So a couple of things to notice is that the distance that the person is away from the mirror, although the person is located some distance x, is really irrelevant. I didn't even have to mention that. So if the person were closer to the mirror, you would still need a mirror that was exactly half the height of the person, and if the person was further away, you would still need a mirror that was exactly half the height of the person. The other thing that's important is the location of the mirror. So this mirror would need to be exactly where I have it placed. I couldn't put it up higher, I couldn't have it lower if I'm looking straight into the mirror to be able to see exactly the top of the head and the bottom of the feet. So that location in terms of the vertical location is important. So just in terms of what the person would see, we know that for a plane mirror, the image that's formed is exactly the same distance behind the mirror as the person is in front of the mirror, and it's exactly the same height. So what the person's eyes are actually interpreting as the light, the person interprets the light as traveling in a straight line and basically coming from behind the mirror. And so if I follow that ray of light back, I see that that light seems to be coming from the top of the head. Now this is a virtual image, so the light doesn't actually originate from that location, but it appears the eyes only believe that light travels in a straight line, so it appears that the light is coming from that location behind the mirror. And the same thing is true for the feet. If I follow the ray of light that bounced off of the mirror, but I follow it back in a straight line, I get the location of the feet in the mirror. So we can see how a plane mirror forms an image and how it is upright, and it's the same height and the same location behind the mirror. So if you wanted to see something, maybe you were wearing a hat on your head, right? And you wanted to be able to see the hat in the mirror. The only way to see more of the space around you would be to make the mirror larger. So you can't change the location of the mirror to see more of your image. Now, obviously I could move the mirror up or down, but I would actually, if I had a plane mirror that was stationary, I would have to make the mirror larger at the top if I wanted to see a hat that was on the top of my head. Hopefully this helps with understanding why the minimum mirror height needed to see a full image is exactly half the height of the person who's looking in the mirror.